Good afternoon, everybody. Today we are going to extend what we learned about yesterday with our graphing linear equations just a little bit further. I want to show you one additional way that will be helpful in figuring out which side to shade once you have graphed your line. Okay, so example one, jumping right in. Graph y is greater than 3x minus 7 by testing a point. Okay, so first of all, what we are doing is we are going to graph the line y equals 3x minus 7. This is the line where your y-intercept is -7, right here, and your slope is 3. So up 3 over 1, up 3 over 1, and then I want to graph this line. I've got enough points at this point. However, I need to make sure what kind of line I'm going to use. This greater than, meaning it cannot equal, tells me that what I'm going to do is I'm going to draw a line that is dashed, which is not coming up right now. Oh. I'm going to draw a dashed line through those points. And I will just correct this a little bit. I think maybe in my last video I had forgotten to put arrows on these lines that I'm drawing. So I will do that right now. There are now arrows. I need to label this y greater than 3x minus 7. And then I, of course, need to label my axes x and y. However, I'm not done. I need to figure out which side of this to graph. Sometimes it is a little bit tricky to figure out which side actually needs to be graphed. You can probably figure this one out without doing this, what I'm going to show you right now, but I want to show you how you'd use a test point to figure out which side to shade. What we are going to do is we are going to pick a random point that is not on the line. If at all possible, pick that point right there, 0, 0. Okay, and then what we are going to do, just messed up something. What did I just mess up? Nothing. All right, then what I'm going to do, once I pick that point, I'm just going to change the color of my magic pen. Once I pick this point right here, 0, 0, I'm going to plug it into my inequality. So if I plug in 0, 0 to y greater than 3x minus 7, that means y is going to be 0. 0 is greater than 3 times 0 minus 7, which means 0 is greater than -7. Now all we have to do is figure out if this is true. If this is true, then I shade the same side that my point came from. If this is not true, that means the whole side is not solutions, and I shade the other side. Well, turns out that 0 is greater than -7, so what I'm going to do is I'm going to take my highlighter. I'm going to shade the same side that had that point that I just picked on in it. And I am done. You can do this with any point whatsoever. Any point that is on this side of the line will give you a true statement. Any point that you pick that's on this side of the line will give you a false statement. So that gives you everything you need. Now what I want you to do is I also want everybody to realize what we're talking about. So in addition, on all of these problems today, I'm going to be asking you to list 5 solutions to the inequality and 5 non-solutions. Just so everybody is clear, where we find our solutions is on this side right here that is shaded in. So all I need to do is pick 5 different points. Here's one right here, here's one right here, here's one right here, here's one right here. Pick any 5 points from this side, and those are solutions. Likewise, to pick 5 non-solutions, any 5 points that are on this side of my line will be non-solutions. So I am not going to give you all 5. We'll do a couple together. 0, 0, like we already figured out, is a solution. How about -6, -5 right here? -6, -5. And how about this point right here, 2, 8? 2, 8. And you pick the last 2. For non-solutions, I go to the other side. Any point on that side is not a solution to this. So how about 6, 2, or 6, -2? 6, -2 is not a solution. Let's pick one other one. How about 10? No, how about 10, 5? 10, 5. That is also not a solution, and I'll leave it to you to pick the last ones, the last 3. However, I do want to stop for just a second and talk about what it means to not be a solution. So let's take our inequality, y is greater than 3x minus 7, and try to plug in one of these 2 points that I just said were not solutions. How about 10, 5? So I plug in 5 for y, 10 for x, and I solve. 5 is greater than 30 minus 7. So 5 is greater than 23. Is 5 greater than 23? Absolutely not, because the point 10, 5 was not a solution to this inequality. So you will get false statements for non-solutions. You will get true statements for solutions. All right, now let's try one more thing with the test point. It wasn't really, or actually, let's talk about what a test point is a little bit more. A test point is an x-y pair that we plug in for x and y in an inequality to see if we get a true statement. True statement is the key word there. If we do get a true statement, then that side of the boundary, or that side of the line, contains solutions. Otherwise, meaning if we don't get a true statement, the solutions are on the other side, what we just talked about. And where it comes in handy is when we do not have things solved for y and we don't want to solve them for y. For example, this equation right here, which is, by the way, you should recognize as 2-intercept form, except that it's not an equation, it's an inequality. I want to graph x over 3 plus y over 6. Remember, 3 is my x-intercept, y is my y-intercept, is less than 1. Because I don't have this solved for y, I don't really know which side to shade. And I don't really want to solve it for y because that would take a little bit of time. So what I'm going to do is take a test point, and remember, anytime you have the opportunity, pick 0, 0 as your test point because it makes it really easy. Look what happens here. 0 over 3 plus 0 over 6 is less than 1. 0 over 3 is 0. 0 over 6 is 0. Is 0 plus 0 less than 1? Meaning, is 0 less than 1? Yes, it is. So the side of the line that has the test point is also the side of the line that has solutions. And that's it. That's all test points are. Okay, so let's do a couple more. Graph x is less than or equal to 9 by testing a point. Granted, you really don't have to test a point here, but I want you to get in the practice of doing it. So we're going to do it on some that we know is true. The line x is equal to 9, everybody should know by now, is simply a solid line now because it can equal, and it is going to be vertical at x equals 9. I clearly need to move this over just a little bit. So I move it over. I'm going to label x, y, and my line, x, y. This is x is less than or equal to 9. And I need to figure out which point, or which side of this line to shade. Again, I'm now going to test a point. I'm going to test 0, 0. Of course, I don't need to plug in anything for y because my equation is x is less than or equal to 9. So I plug in 0 for x. Is 0 less than or equal to 9? Sure is. So what do you know? I shade the side that has the origin in it. That's a test point, everybody. It's really that simple. Now I want you to pick 5 solutions and 5 non-solutions. Let's do one together. One solution is clearly going to be 0, 0, like we just found out. One non-solution is going to be on the right of the line. How about the point 10, 0? I leave it to you to pick the other 4 solutions and other 4 non-solutions. It should only take you a few seconds. Okay, example 3b. Notice 3b is here on purpose. I want to graph 2x plus 3y is less than -6. And I want to do it by testing a point, so I do not need to solve for y as long as I know how to graph this sucker. And that's where we come into trouble because I bet several of us don't remember how to graph this sucker, which is why this is exercise 3b. let's go on to 3a, which is on the next slide. And now I'm going to graph this equation. Notice it's an equation now, not the inequality. And the way I can graph any linear equation is by finding my x-intercept and my y-intercept. X-intercept is where y equals 0, so I do 2x plus 3 times 0 equals negative 6. That's 0, so I get 2x equals negative 6. Solve for x, I get x equals negative 3. So one point is negative 3, comma, 0. Oops. All right, I can't do that with the magic pen. So negative 3, comma, 0 is 1 point on my line. That's the point that has the x-intercept on it. And I will just draw that in on my graph. Let me undo that. Negative 3, comma, 0. I wasn't paying close enough attention. And so I have my point there. Next, I find my y-intercept. This is where x is equal to 0. So I do 2 times 0 plus 3y equals negative 6. I get 3y equals negative 6. And so I get that y is equal to negative 2. So my point is 0, comma, negative 2. And I'm going to graph that. 0, comma, negative 2 is right here. And so that's how I graph a linear equation. This is in standard form, if you remember. I can then just draw my line straight through it, more or less straight through it. I can adjust mine just a little bit. Arrows on both sides. And do not forget to label stuff. Y, x, this is 2x plus 3y equals negative 6. Notice no shading because all I'm doing right now is graphing the equation. And if I want to talk about solutions, 5 solutions to the equation, 5 solutions that are not the equation, all I have to do is look for 5 points that are on this line, which means I need to make my line a little bit more perfect. Right there. So clearly, 2 solutions are the points I just found. Negative 3, comma, 0, 0, comma, negative 2. Any other points on the line, it looks like there's one right there. Looks like there's one right there. Any other points on the line are also going to be solutions. So you can go ahead and find several of them and check and plug them into this equation here just to make sure that you found correct points. 5 non-solutions, that's much, much easier. Just pick any points that aren't on the line anywhere. Okay. The first one I drew looks like 7, 6. The second one I drew is nowhere. So let's say I meant this point right here, negative 6, comma, negative 7. That's it. Okay, now what I'm going to do, I'm going to take this entire graph, like so. I'm going to copy it. You cannot do this. You'll have to copy yours in manually. I'm going to delete this. I'm going to paste this in. Now I have the graph that I just drew in. However, I now want to change this to where I am graphing less than. So I change this to be less than, which means I need to change this graph to dotted or dashed. And now I'm going to figure out which side to shade by using a test point. Test point, going to be 0, 0. What do you know? I plugged 0, 0 in. 2 times 0 plus 3 times 0 is less than negative 6. All of this is just 0. 0 is less than negative 6, which is not true. So because it was not true, I'm going to shade the side that does not contain the test point. If the test point gives you a true statement, you shade that side. If it gives you a false statement, you shade the other side. And then list 5 solutions to inequality and 5 non-solutions. By this point, I would hope that you can do that, so I will leave those to you. And then we're going to move on to our final example that we're going to do together, graph x plus 5y. Let me just make sure. Yeah, there's a your turn next. So graph x plus 5y is less than or equal to 10. Again, I'm going to graph this very quickly by using my intercepts. The x-intercept is where y is 0. So x plus 5 times 0 less than or equal to 10. Actually, I'm going to graph the equation, so equals 10. So I have x equals 10. So 0, or sorry, did that wrong? The point is, be very careful when you're drawing your labeling your point. Your x-intercept is 10, so the point is 10 comma 0. And so I get 10 comma 0 right over here. Next, y-intercept is where x is 0. So 0 plus 5y equals 10. And so I have 5y equals 10. And so y equals 2, which means the point 0 comma 2. 0 comma 2 is right here. I draw my line in, dashed. Oops. I need a dashed line, or I'm sorry, do I need a dashed line? No, I need a solid line. Left and right arrows. I was having some trouble drawing that line, so let's do it one more time. Turn it into a solid line. Left, right arrows, solid line. Turn it red so it's more visible. Okay, that's it. I have graphed this. Now I need to figure out, is this which side to shade? Use my test point of, once again, 0, 0. I get 0 plus, I'm still with my magic pen, 0 plus, let's try this one more time. 0 plus 5 times 0 equals, or is less than or equal to 10. Well, that's 0, that's 0. So is 0 less than or equal to 10? It sure is. So the point that has the origin is definitely the side that has the solutions. Graph those in. You're going to list out 5 solutions and 5 non-solutions, and you're going to try the U-turn, and we are done.